Welcome to our P.D training video on proton device construction. So as you can see, I have the P.D software open and I'm logged in. Typically the first step you will need to perform when setting up your site is going to be establishing the communications between your treatment planning system and P.D. Once you have those set up, you'll notice that P.D will automatically import your patients through the DICOM listeners that you set up and establish at that initial install time. So you'll see that your Proton patients actually will import and show up right in the top of your recent patients list, just as mine is shown up here. So typically, once you've initially set up P.D, there's no extra work to import or bring your patients into P.D. Whenever you export them from your treatment planning system, they will automatically import and show up here in the recent patient list as long as P.D is running at the time of export. Okay, so we're going to go ahead and open our Proton plan. And typically, for those of you in the clinics, you won't see this screen because you will typically also, on commissioning of P.D, you will also have set up a machine that has the name of your machine from your treatment planning system. So you'll notice from my DICOM files, here's my machine name for this plan. Well, P.D was unable to find that exact machine name in its system. So it's giving us a list of all the available Proton machines that have defined the snouts. I have one that's pretty close here, slightly different from that one, but I actually want to use the decimal Proton example in this case. Okay, so I'm going to select that machine. Like I said, typically this screen won't be presented to you because you'll have a machine that is defined with the appropriate name for your site. Then once P.D loads, you'll see that P.D is actually going to immediately construct all the parts for us. Okay, unlike some of the other types of parts in P.D, there's really no extra inputs beyond the machine setup for Proton parts, so P.D will automatically compute all of our parts for us. So if we look at the 3D view and turn on all of our parts, we'll see all of our range compensators and all of our apertures have automatically been created as soon as we import and open that plan. So if we kind of look at these one by one, we can see our aperture, can verify that the thickness is correct, that the size looks correct, and that the general cutout shape is what we define in the TPS. We can turn on our range compensator. I'll take a second to describe the range compensator view that you see here. The small hexagons here, this is using an offset grid spacing for our range compensator. So what you see as a square with the varying heights, that's the actual modulated surface of the range compensator that came in from the DICOM file. And then what you see as the circle is the actual range compensator diameter onto which this surface will be machined. Okay, so we can verify that the snout size setting is correct, that it's selected the correct blank size for our range compensator, and we can verify that the modulating surface looks as it was in our treatment planning system. We can also turn our block on with it and verify that the opening appears in the correct location relative to the compensator. And we can also actually do that in beam's eye view as well. So if you click on beam's eye view, we can see each of our 3 different beams. And in our beam's eye view, we have basically the same information. We have our range compensator here shown as the white map. The dark spots are the thinnest sections of the range comp, and as we get closer to a white color, we have thicker and thicker sections of the range compensator. The yellow lines indicate the lines of constant height on our range compensator, so we can see kind of the constant height plateaus or shelves along our range compensator. We also see the red line is our aperture opening, and then we see the dashed white line is our actual range compensator blank size, our outside diameter of our range compensator. So once we've reviewed our parts, you're actually done, you're ready to order. So immediately when the plan comes in from P.D, or into P.D, you've got all the information that you need to go ahead and order your parts. Okay? Remember, if any of the names or any of these are not correct, when you're in the order wizard, you can change the names simply by clicking on them. This will be what's engraved on your part. So if you want to change that compensator ID that will get engraved on your part, you can do so in the order wizard. Okay? You'll also notice sometimes for larger diameter range compensators and apertures, you'll notice the large apertures are split into slabs. So in this case, we see that these apertures are 1 slab each. That's the 1x. So if you have a large aperture that comes into P.D and it's thick, you'll see the number of slabs that P.D has computed that will need to be created for that device as well. So that information will be right here with it, so you can see how many slabs are necessary. All right. On the rare chance that there's a problem with computing your range compensator device, you'll notice that it just will appear to be missing from the beam. So if you know that your treatment planning system had defined range compensators for all of your beams, but one appears to be missing in P.D, that means P.D had a problem computing that range compensator. Okay, since it does that on import, it doesn't know if the user will actually be there to see that error message, so you may not have seen an error message. If you go into the Proton wizard and you just click Create Compensators, it will recreate the compensators and it will display any error messages for you. Okay. The other thing you can use the Proton wizard for, and I'm going to cancel out of here, suppose you aren't sure what the problem is. Well, sometimes the problem with the range compensators can be that the actual range compensator is too thick or too thin to be manufactured by dot decimal, or too thick according to your machine setup parameters. Okay. Or with an aperture, the aperture opening may be larger than the actual aperture diameter, in which case it can't be manufactured and it won't appear in the list. So if you have a problem with your machine setup, you can go into the machine setup, you can change the machine. Remember, you cannot edit the from plan machine, so you have to go to the actual machine in the list, go to the Proton tab, and you can edit any of the parameters of your machine. So if there was a mistake in one of these diameters or one of these sizes, and that's the reason why the part didn't open, typically you'll get those worked out the first couple times you start using parts in P.D. But the other thing you can check in this machine setup, you can check the max thickness of your range comp. On occasion, your treatment planning system may design a range comp that's thicker than what you've listed here as the maximum. That could be a reason why your range comp was unable to compute. If you change any parameters in that machine, the parts are not regenerated automatically. That's what the Proton Wizard is here for as well. So you'll come into the Proton Wizard, you'll select a new machine. Remember, you can't edit the plan machine, so this is not the one that you want to select. You want to select the one with the same name, but without the plan on it. So if you've edited the machine and need to regenerate your parts, simply change the machine and click Create Proton Compensators. I didn't change anything, so you'll see it recomputes those very quickly. And once you click Finish, you've now regenerated all your Proton parts and you're ready to order. Okay, that shouldn't be necessary for most parts. So the typical use of P.D for Proton parts, you will simply open your plan. You won't even need to select your machine. That will be done for you. You'll verify that all of your parts are correct. You'll notice I selected a different machine. That's why my diameter seems to be a little different here. So you'll verify that all your parts appear correct. So I'll look through Beam's Eye View on each of my parts, verify they're correct. Once I'm satisfied, I go ahead and I order my parts. It's that simple with P.D.